Prehistoric animals are known for their bizarre adaptations, often unreal body size, and incredible diversity. Some of those adaptations include defensive and offensive weapons, the topic of today's conversation. We'll be covering prehistoric animals' most extreme weapons, starting with the dangerous but relatively benign entries in the paper-cut tier. We'll take things up a notch with the serious threat tier, and cover the biological equivalents of a nuclear option with the Overkill tier, discussing how these amazing animals would utilize their specialized structures in defense, hunting, and competition. Academic sources are in the description. First up is the paper-cut tier, which includes animal weaponry that is certainly dangerous but represents the floor for this video. We begin with the spiked frontal appendages of Anomalocaris, a 1.5 foot long apex predator from the Cambrian. Anomalocaris was a radiodont, a group of marine arthropods with a circular crushing mouth called an oral cone. It was thought for many years to have hunted trilobites with its frontal appendages by crushing their armor with its spikes, but the lack of damage or mineralized content on said spikes cast that hypothesis into question. A 2023 biomechanical study suggested instead that Anomalocaris would have been an open-water pursuit predator that hunted fast, soft-bodied prey. Its appendages were flexible and could extend and contract quickly, but wouldn't have been able to pierce trilobite armor as long believed. Still, they're formidable-looking structures and deserve a place on the list. Another set of weapons recently demoted by biomechanical analysis are the hand claws of Therizinosaurus, an herbivorous megatheropod from late Cretaceous Mongolia. In the early 2000s, it was popularly depicted as a Freddy Krueger slasher villain of an herbivore that used its enormous claws like knives to defend itself against Tarbosaurus. That actually continued on into 2022 with it stabbing all the way through Giganotosaurus's neck in Jurassic World Dominion. Unfortunately, neither of those depictions seem realistic in the wake of Chin et al. 2023, which used finite element analysis to stress test various Alvarezsaur and Therizinosaur claws. Turns out, Therizinosaurus's claws were so long that they weren't as combat viable as thought, instead serving as a decorative tool for interest-specific display, hooks for grabbing vegetation, or simply looking scary to predators. Still, from the perspective of a human, a 3-foot-long claw is absolutely horrifying. It would still take you out pretty easily and do damage to attackers. That's the end of natural weapons that weren't as dangerous as we thought. It's all crazy stuff from here on out, even within the rest of the paper-cut tier. The bite and claws of Velociraptor, a 14 to 20 kilogram dromaeosaur, may have been relatively small but could do serious damage. Velociraptor also lived in late Cretaceous Mongolia and was first found in the flaming cliffs of the Jodokta Formation in 1923. According to Sakamoto 2022, it had a relatively low bite force of 304 Newton, which is still comparable to modern cheetahs according to Rowe 2007. Its skull was long and thin, lined with small, curved teeth perfect for snapping up small prey, and its iconic sickle claws could have been used to pin down small animals as it ate them alive. They may have also performed a defensive function, as seen in the fighting dinosaur specimen, in which a velociraptor pinned down by a protoceratops has its sickle claw hooked in the ceratopsian's throat. We don't know who started this scrap, but it's clear that even the ancient herbivores of the Cretaceous were not to be messed with. Speaking of primitive ceratopsians, the bite of Udanoceratops was formidable in its own right. Udanoceratops was yet another denizen of late Cretaceous Mongolia, which seemed really good at producing an incredible diversity of amazingly terrifying animals. It was about the size of a cow, at 3 to 4 meters or 9 to 12 feet long and weighing 700 kilograms, or 1,500 pounds. It had the superficially parrot-like skull shape common to many leptoceratopsids, but overbuilt to an absurd degree. Its mandible, or upper jaw, was thick and robust, and its dentary resembled a curved guillotine blade. That powerful bite would have been useful for harvesting tough plants as well as self-defense, both against predators and competing members of its own species. I'm not one of those paleo Twitter bros that thinks every herbivorous animal is secretly a raging maniac, but I'll say this, don't mess with herbivores just because they eat plants, especially ceratopsians. Our last entry in the paper-cut tier is rather broad, saber-tooth. We see saber-tooth develop in multiple clades throughout time, some only distantly related. The first are my favorites, the Gorgonopsians. These non-mammalian synapsids lived in the Permian period and were terrestrial apex predators before dinosaurs were even an idea. The biggest, Inostrancevia, grew to about 350 kilograms, or 770 pounds. Its 6-inch, 15-centimeter canines were robust and serrated, capable of piercing scales and flesh of the cow-sized pariasaurs it lived with, as well as similar-sized prey to themselves. Their columnar stance and symmetrical feet would have made them fast runners. Even though their skull structures led to relatively weak bite forces, Gorgonopsians still would have been able to puncture bone, according to Benoit et al. 2021. Saber-toothed cats, and cat-like saber-tooths, filled broadly similar niches in the Cenozoic. They had decently strong bites with wide gapes, along with powerful forelimbs built for grappling. Also, a lot of animals that the public would recognize as saber-toothed cats aren't even cats. Nimravids, which include Barbarafelids, are outside of the true cat group Felidae, but convergently evolved very similar builds and hunting styles. Even within true cats, we have the Metylorini like Dinophelus, the Smilodontidae like Smilodon, the very heavily built homotherine Mechairodontines like Amphimechairodus, and the more slender homotherines like Homotherium. This shows how useful the saber-tooth grappler build is for taking down cow-sized plus prey across time, given how isotopic studies show that Smilodon fatalis was eating the enormous Bison antiquus. Their combination of saber teeth and claws was great for hunting animals larger than themselves, especially given how mechanical recreations of big saber-toothed cats indicate that biting the throats of big animals would have been the most efficient way of taking down their prey. On the topic of prehistoric weaponry, my epic fantasy novel Obsidian Dawn is now available as an ebook and hardcover. You can find it on Amazon, Ingram Spark, and Kobo. Obsidian Dawn is the first in a trilogy covering a war between the Aztecs and Carthage, but both sides have psychic dinosaurs. Links will be in the pinned comment. On to the serious threat tier. Himalayasaurus tibetensis was one of the biggest predatory animals in the history of the planet. This 15-meter, 35-ton ichthyosaur lived in the late Triassic period and had massive serrated teeth, laterally compressed like a theropod dinosaur's. We don't know exactly what the back of its skull looked like, but the interior portion preserved gives us an idea of a gigantic, powerfully built animal. It's not higher on this list because of its fragmentary nature, but Himalayasaurus would have been able to prey on just about anything other than even bigger predatory ichthyosaurs. And if the recent discovery of stealth-enhancing structures on the fins of Temnodontosaurus is any indication, then Himalayasaurus may have been a deep-water ambush predator as well, which is a horrifying thought. Eurypterids, informally referred to as sea scorpions despite not being scorpions and also including a significant number of freshwater species, are amazing. They include some of the biggest and most heavily armored arthropods in Earth's long and glorious history of arthropods. A specific group, the pterygonids, developed long, grasping chelicerae claws for prey capture. The biggest of them were about 2.5 meters long, not including the claws, and would have weighed several hundred kilograms, so their chelicerae would have been like wood saws that could close around their prey. Interestingly, their claws were the only parts of their body that were heavily mineralized, indicating that the rest of their armor was extremely thin in order to allow for their exoskeleton to function properly, even underwater. Eurypterids may have reached the largest size biologically possible for arthropods. Pretty amazing if you ask me. Ceratopsian horns are next, well, the ones that were likely used for combat anyway. I'm not talking about the absolutely gorgeous, while non-combat applicable structures that we see on the frills of ceratopsians like Lokiceratops or Cosmoceratops. We're talking sword horns like the ones we find on Triceratops, Coeloceratops, Torosaurus, Machairoceratops, Styracosaurus. Heck, even the sharpened spikes we find above the nasal boss in Pachyrhinosaurus lacustae. While the prevailing hypothesis is that these structures originally evolved as a form of sexual display, that doesn't mean they didn't also function as predator defense and interspecific competition tools. A 2023 study concluded that the placement of Triceratops horns, for example, along with injuries in skull bones of the species, indicated that they likely locked horns and stabbed each other in the face in order to establish dominance. Other ceratopsians would have had unique horn-locking positions according to their skull structures. And others, like those with nasal bosses or a single horn, may have engaged in flank ramming to inflict maximum damage. On to bear claws, and I'm not referring to the pastry. Modern bears like grizzlies can have claws 5 to 10 centimeters or 2 to 4 inches long. Giant prehistoric bears like Arctodus simus would have had comparable weaponry, although since they weren't as adapted for digging, their claws wouldn't have been as long. Their claws were powerful and sharp, however, and backed up by 600 to 1,000 kilograms of muscle, could have dealt out absurd damage to rivals or unlucky victims. Don't forget about their teeth either. Being an omnivore doesn't mean that these bears had weak bites, and their canines were sharp and thick. Arctodus simus would have been Leonardo DiCaprio's worst nightmare. Megaraptoran hand claws were another serious threat, especially for human-sized prey animals. Megaraptorans have huge curved ungual phalanges or finger bones that included claws. They curved down and inward, excellent for capturing prey like gigantic fishhooks. In Megaraptor proper, the hand claws are about a foot long, or 30 centimeters. That's not including the keratin sheath that it would have had in life. Megaraptor itself is far from the biggest member of the clade. That honor, at least for now, likely goes to Maip macrothorax, whose genus name means cold wind of the shadow of death. It's named for an evil spirit from Ionicenc or Tehuelche mythology. Maip was about 9 to 10 meters long and would have weighed about 3 tons. While the claws from the specimen weren't preserved, they likely would have been even larger than in Megaraptor, which was a third of the weight. I'm of the opinion that, if you were to get teleported back in time to the Cretaceous, Megaraptorans would be one of the dinosaurs most interested in eating you. We can't have a video on prehistoric weaponry and not mention the pinning claws of the large dromaeosaurs, in particular Utahraptor. Utahraptor is quite robust for a dromaeosaur, with a thick short skull and large clawed arms. It's also the size of a polar bear, with 24 cm sickle claws in the largest specimens. One popular idea on how that would have been used is the raptor prey restraint model, which is that the claws would pierce and pin down struggling prey while the raptor ate it alive. A potential flaw with that model that's been pointed out in the comments of a previous video is how modern birds of prey that engage in such behavior typically have a rear-oriented and well-developed hallux to ensure a strong grip. Perhaps the sickle claw filled that role given its large size compared to other toe claws and dromaeosaurs, but one thing's for sure, we always need to be incorporating new information to improve our models on ancient animal behavior. As the saying goes, all models are wrong, but some are useful. Before we start on tails, we have one more set of claws to highlight, Spinosaurus. While the holotype didn't preserve any arm material, referred specimens include several manual phalanges and unguals that proved to be quite intimidating. Large adults would have had claws about as long as an adult human's forearm, perfect weapons for capturing and gutting the enormous fish that they lived with in Cretaceous North Africa. Shunosaurus was a sauropod that lived in China during the Jurassic period. While quite small for a sauropod at just over 9 meters and about 3 tons, it made up for its diminutive size with its fierce tail club. The knob of bone had 2-inch or 5-centimeter spikes growing from it that would have done significant damage to any predators unwise enough to attempt attacking it from behind. It lived with small metriacanthosaurids like Synraptor, and larger taxa like the Indian elephant-sized young Schwannosaurus, which was its most likely natural predator. Jurassic China was wild. Tail clubs go to the next level with Ankylosaurus, the 4-ton living tank from Maastrichtian North America. If you're an herbivore coexisting with Tyrannosaurus, you need to be crazy fast, crazy offensive, or crazy defensive. Anky went for the last option with a body covered in thick bone plating, along with a fused tail club 1/2 meter or 1.5 feet wide. It's basically walking around with a small boulder, ready to thwack the shins of anybody trying to mess with it. The club was held straight by the fusion of 7 caudal vertebrae preceding it, which together acted like a natural handle to keep the club and tail level, despite its immense weight. Steguros from South America took a very different approach. This wee little ankylosaur lived in Patagonia during the late Cretaceous, and instead of a hammer-like tail club, sported a mockweed-like tailed sword club. It's almost as if evolution itself is reminding you that Aztecs and dinosaurs go together. Crazy. Anyway, Steguros was a small dinosaur, about the size of a medium dog, and likely used its sharpened tail osteoderms as a threat display and effective weapon. The tip of the tail weapon was stiff, but the tail itself would have been able to move back and forth to strike enemies on either side of Steguros. I really hope we find more animals with this type of defensive weapon. We made it to the Overkill tier! I don't know if that's a good thing, given the intimidating name, but here we are. We're starting off hot with Stegosaur thagomizers. These meter-long tail spikes get their name from the legendary Far Side cartoon, in which a stylized caveman named Thag Simmons is reported to have been killed by a Stegosaurian assault. The name stuck, and now that's what pretty much everybody has called them since the 80s. And while thagomizers themselves are formidable, shown to be able to pierce bone and brutalize Allosaurus specimens, a huge part of what makes them dangerous goes beyond the spikes themselves. Stegosaurs are shown to have an incredible range of motion with their tails, as displayed in Malice in 2010 with Kentrosaurus. They could swing their tails to the side to the point that they were facing forward, resembling an herbivorous multi-ton scorpion. Add to that the Stegosaur itself changing angles and turning to face any attackers, and it's little wonder why we have so many Allosaurus skeletons with horrible injuries. Anodontosaurus opts for bludgeoning damage. While not as large as its relative Ankylosaurus, Anodontosaurus has a club tail that makes its more famous cousin cry with envy. The club is wide and thick, but with pointed pyramidal edges like a gigantic sledgehammer. If Ankylosaurus uses Mjolnir, Anodontosaurus is equipped with Stormbreaker. The smaller surface area of its spike-like club edge would act as a force multiplier, crushing skin, muscle, and bone all at once. Anodontosaurus is known from the Dinosaur Park and Horseshoe Canyon formations of Canada, and would have defended itself against predators like the 2 to 4 ton Gorgosaurus, 1 to 3 ton Albertosaurus, and 3 to 4 ton Daspletosaurus. If you live alongside fast, bone-crushing tyrannosaurs, one of the best solutions is to become a bone crusher yourself. We have another Cenozoic entry with Coelodonta, specifically the wicked horns of Coelodonta antiquitatis, the famous woolly rhinoceros. It only went extinct about 10,000 to 14,000 years ago and was one of the most formidable animals to roam Pleistocene Eurasia. At up to 2+ metric tons, it was a muscular herbivore that could back up its wicked 1.5 meter nasal horn with serious force. The horn itself was more thin and blade-like than modern rhinoceros horns, giving it a unique morphology within its clade. A hit from something like that could gash open just about any predator that Coelodonta could have encountered in the Pleistocene. But some earlier predators were specially adapted for hunting horned creatures 5 times Coelodonta's size. That brings us to the jaws of the tyrant lizard king, which had the strongest bite of any land animal known in the history of the planet. The most recent bite force study that included T-Rex, Sakamoto 2022, calculated that Stan, a decently sized, plausibly adult T-Rex, would have bitten down with a force of 24,000 newtons at the front of the jaws, where the force was weakest. The rear bite force goes up to 48,000 newtons. Even larger specimens could have bitten in the 60 to 70,000 newton range. For reference, a 2021 study found that bone-crushing bites start between 1 and 3,000 newtons, forces that T-Rex was likely achieving as a baby. Its jaws were optimized for seizing prey and shaking it, with large, D-shaped teeth that could pierce and hold structures like ceratopsian horns and frills. HAP 2008 reports a bitten-off Triceratops horn, showing that T-Rex was perfectly willing to attack and damage dangerous prey by removing their defenses. We go back to the Cenozoic for a moment to highlight Didacurus, which had probably the nastiest tail club out there. It was robust and covered in huge spikes, and may have been used for intraspecific combat over mates as well as brutal predator defense. It's basically the Witch King's Morning Star but on a disgruntled armadillo relative. The tail club was about the size of a human torso, not including the spikes, so one hit from this thing would just about pulverize any predators that Didacurus could have potentially encountered. Smilodon, Jello. Short-faced bear? Jello. Jaguar? Jello. You get the point, and so would they. Let's dive into the water to look at giant crocodilomorph jaws. I'm also including animals that aren't true crocodilians in this section, like the 9 to 10 meter Philetosaurus sarcosuchus and the enormous Phytosaur Smilosuchus. Animals in the semi-aquatic ambush predator niche tend to have fairly similar body plans, with short limbs, powerful tails, and bone-crushing jaws, unless you're gharials, which specialize in eating small fish. Purosaurus was the king of Miocene Brazil, with a wide, almost cartoon-like skull perfect for crushing large mammals into bits, and Deinosuchus was a terror in late Cretaceous North America. The very biggest pseudosuchians seem to cluster around the 10 to 11 meter and 5 to 7 ton mark, dwarfing even the largest saltwater crocodiles from today. But even they didn't have the biggest, meanest jaws in the Mesozoic. That honor probably goes to a pliosaur like Kronosaurus or Sachicosaurus, which were bobble-headed super carnivores that ruled the Jurassic and still had a significant presence in the early Cretaceous. Sachicosaurus was one of the very largest known from good material, at over 10 meters long and 15 tons, with a toothy skull 3 meters long. It could have swallowed a human whole, and would have used its jaws to crush and rip apart prey like elasmosaurids and giant turtles. Fragments exist of even bigger pliosaurs, and you can learn about them by checking out my recent video on the subject. Spicomellus afer recently made headlines for basically being an awesome bro kaiju ankylosaur that also happened to really exist. In 2021, a dorsal rib with spiky osteoderms became the holotype for the genus and was thought to represent an African ankylosaur, but nobody was sure of what the rest of the animal looked like. Fast forward to 2025, and with a description of more material, it turns out that Spicomellus was a 5-meter hedgehog anguirus of an animal with spikes covering its neck, sides, back, hips, and tail. Its tail vertebrae were stiffened and fused into handle vertebrae, which indicate that the tail spikes it possessed could have been used somewhat like stegosaurian thagomizers, albeit with less flexibility. The author suggested that its armor pulled double duty as predator defense and display, which makes perfect sense to me. If evolutionary pressure selects for a particular structure, it may very well have more than one function. Big sauropod stomps and tail slaps are next. While not explicitly weaponized structures in the same way as many of the other entries on this list, the feet and tails of big sauropods were devastatingly powerful. The sheer force exerted by a 40-ton Brachiosaurus or 90-ton Argentinosaurus would have been mind-numbing, whether it was stepping on you or slamming you into next week. As fully grown adults, many sauropods would have been immune to predation. There simply weren't any carnivores large enough to take them down. Livyton melvillei had the largest teeth known of any animal. Period. While only known from a skull, this hypercarnivorous sperm whale relative was armed with sharp teeth a foot long, inside of jaws 3 meters long. Its actual body size is uncertain, given the complete lack of postcranial material, but by any standard it was a titan among marine predators. It would have hunted sharks and other whales, and even coexisted with Otodus megalodon. While recent discoveries and analyses indicate that this shark was likely more slim and elongate than traditionally reconstructed, it was still a gigantic predator. Adult megs range between 9 and 16 meters long, with large individuals pushing well over 30 metric tons, and the very largest record-breaking 1 in 20,000 individuals exceeding 24 meters and weighing nearly 100 tons. Their teeth were many and massive, with a broad shape and serrated edges. Bite force estimates for the megatooth shark range from 108,000 newtons for a large 47-ton individual to 182,000 newtons for a 103-ton exceptional individual. It must be noted, however, that those estimates originate from isometrically scaling up a great white shark, and that morphologically, Megalodon likely would have been more gracile. Bite force also doesn't quite scale isometrically, so more accurate estimates should be about a third lower, regardless of the phylogenetic controversy. Still, that's an absurdly powerful bite, which is nothing less than expected for the largest confirmed macropredator in the history of planet Earth. Thank you for watching, and don't forget to check out Extinction Obsidian Dawn in ebook and hardcover. I've spent years working on this series, and I'm thrilled that I can finally share the first book with you. You can also subscribe for more videos like this and join the channel for various perks, including shoutouts and loyalty badges at the Raptor tier. At the Megatheropod tier, which is only for people who are truly crazy about prehistoric life, you also get early access to videos. I'm the Vividen, and I'll see you the next time I get the itch to make a clickbaity video title that's backed up by real science.